Okay, so let's start today's class. If you remember, last class we have discussed some problem. Before that, we have been discussing about the diffraction and we have seen up to plane surface. Now today we will go into refraction through spherical surface. So let us go into that topic, diffraction through spherical surface. Refraction through spherical surface. Surface. So let us say that there is a spherical surface, then this surface can be anything, can be concave, convex, whatever it is, but there is a medium. So this side, let us say that medium is 1, refractive index and 1, this side is medium 2, refractive index and 2, and let us consider that this is the optical axis. This is called optical axis. Optical axis. And this point is called point O. This is called optical center. Optical center. Now suppose if I take any object, okay, we can talk of object anywhere, of course. In this way we can keep anywhere object, okay, but generally when we are seeing the horizontal distance, but definitely we can keep anywhere object. Let us consider that object is anywhere, but let us take that this object is here. We can keep it anywhere definitely. Hmm. Then we can study x and y and all that. Okay. Suppose if I take on the optical axis, this is the object. Let us call this object as object A, and let us say that this is the some center we need to define, right? Because we need to drop a normal. So if I consider that the center of this curvature has radius r is the curvature radius, and suppose the center of this surface is somewhere here C. Now I am going to consider some rays. Let us take that I am taking a ray here. This is the ray of light which is incoming or incident ray of light, and then we will be seeing what happens to the refracted ray. So ray of light is going from first medium to another medium, and let us consider that this is the normal here. So definitely from the center, any line, is hitting the surface, that is a normal here. This is a normal. Okay. So this is the angle of incidence here. Okay, angle of incidence. Let us say that this point where incidence happen, then reflection is going to happen. Light rays is bending like this. We let us consider. So this is the refracted ray, this is the incident ray, then this is the angle of incidence, this is angle of refraction, and one ray you can take directly going in a straight line like this. One ray we have to take like this. So this is the another ray. So these two rays are meeting here. This is the image. We have got the point image. This is the object. So let us consider that this distance of the object as x and image distance from optical center is x dash. Okay, and this is the center C. So this distance is radius r, right? So these distances we know all this. We want to establish a formula. Remember again, always there is a confusion in sign. We are not taking right now sign, we are taking distances. So whenever we derive a formula, we take all that as distances. Afterwards, we put the sign convention and we take plus minus later. First, all these lengths, right? X, x dash, r, all these are distances. Okay, right. Then find out relationship between them. Okay, so how to find relationship? Let us try to do that. Okay, so if I take this angle as alpha, this angle as beta, and this angle as gamma, and note that these are paraxial rays, so this point where it is hitting, it is very close to this. So this is like almost like a straight line. Let us say that this straight line has a length of y. Okay, of course this is perpendicular here. So now let us try to find out, because the angles are very small. So alpha, beta, gamma, I, R, all these are very small angles. Very small angles we are taking. So we are taking paraxial rays. Remember, we are taking paraxial rays. We are taking paraxial rays. Okay. So let us try to apply in this trigonometry. Let us apply. So definitely we can see that, suppose if you apply the law of refraction, so n1 sine I is equal to n2 sine R. This is law of refraction, and because the angles are very small, n1 into I is equal to n2 into R. Yes, now we have to substitute I and R values. That I and R values will calculate from here. So tell me, in this triangle relationship is there, what is tan beta? Tan beta, if you calculate, that is y by this distance, which is y by r. And beta is very small, so tan beta is same as beta, so beta is equal to y by r. Okay, we got beta. Similarly, let us take tan alpha. So what is tan alpha? Tan alpha is equal to y by x. Y by x. So angle is very small, so alpha is equal to y by x. Similarly, tan gamma. Tan gamma also let us calculate. Tan gamma. So tan gamma is equal to y by x dash. And because angle is very small, so gamma is y by x dash. So we got this alpha, beta, gamma, and now we want I. I, alpha, beta are related like this. How are they related? We can try to calculate that. Okay, how are they related? So here, how are they related? That is important. So we can see here that beta is exterior angle of this triangle. Beta is equal to alpha plus I. So definitely I is equal to beta minus alpha. I is equal to beta minus alpha. We got this idea. What is I? Similarly, R also we need to calculate. Now think about R. R is the exterior angle of this triangle, so R is beta plus gamma. So from here, R is equal to beta plus gamma. We got it. Now let us substitute that in that formula. But before that, let us calculate beta and gamma. Substitute here and calculate I. So I is equal to beta. Beta is what? Beta is, where is beta? Beta is y by r. What is alpha? Y by x. Okay, this is what is I. Okay, then what is r here? R is beta plus gamma. Beta is y by r. Gamma is y by x dash. We are going to now substitute in the law of refraction. So n1 into sin I or I. So n1 into I is y by r minus y by x is equal to n2 into r sin r, which is r, is y by r plus y by x dash. Okay. Now I am going to take y common and get cancelled. This y terms get cancelled. And let us now try to open this one. So n1 by r minus n1 by x is equal to n2 by r plus n2 by x dash. Bring x terms one side. So n2 by x dash plus n1 by x is equal to n1 minus n2 by r. Note that this is the important, formula. But now see, when we are substituting sign convention, things will be changing. This is actual the raw formula. The raw formula is this. Raw means the scratch formula. This is the formula that we derive. After that, we'll put things and then sign will change plus minus all this. Why? Because we are choosing somewhere a coordinate system, origin. According to that origin, plus minus is taken, right? So let us now put the sign convention. So let's see here that we have taken this point as optical center O, and this is the object, right? Object I have taken as A, right, image I have taken as I. This is the object, this is the object, this is the image I have taken, right. So let me substitute here. What should I substitute? I will substitute x dash. So see, if I consider this as this distance as x, right, and this distance as x dash, right. So I will say that the v, what I am looking for v in this diagram, v is plus x dash only, because v is this side positive, object distance is this side negative. So object distance u I will write as minus x. Okay, and what about the radius of curvature in this? Radius of curvature I will write negative because center is here. This distance is r. But because it is left side, so radius I will write as minus r. Now let us substitute here in this formula and change this. Suppose I change it. So then what happens? N2 by x dash is v plus n1 x. What is x? From here x is becoming minus, you note that, is equal to n1 minus n2 into r. This r I have to put as minus r because in this I have to substitute. Okay, so let us substitute here. So then it becomes n2 by v minus n1 by u is equal to this minus I will take in numerator n2 minus n1 by r. This formula is true. This formula is true. Now suppose if they say that uh, is this raw formula that we have got in terms of x axis, it is also true for other type of shape because we have taken concave here. Suppose if I take convex, will it also be true? Will it also be true? For that again you think, suppose if I take convex, if I take the surface as convex, then r will remain positive. But then you will be substituting, x axis like the same way. Hmm? This you will substitute. So only thing is r will be positive. But if r become positive, then this formula will become n1 minus n2 by that. Yes, things can change, but the raw formula should not change. Suppose I take a, let us say I take a convex surface and try to derive that formula. Okay, let me take a convex surface like this way. I want to take this type of surface. I want to take this as n1 and this as n2. Okay, and let us take this optical center. Take this as optical center. This is the object. Now I take the ray like this way. Okay, now tell me, here the center, let us say center is here, C. So I will draw the normal first of all, like this. Okay, now if I want to draw the ray, this is the angle of incidence here, this angle of incidence I is there. Now how will the ray go? Will it ray go towards or away from normal? That will depend. Let us say if I consider that this is a tensor medium, so ray will go towards the normal like this. Okay, it will because how the normal is, this is the normal, this is I, so this is the angle r, this is the angle r. Okay, now if I try to use, so this is again, this is the image, it is going to have this is image. This distance is, this distance is x, this distance is x dash. Why I am doing is that then I must get the same formula. I want to verify, am I getting this? Today somebody asked me, if you take different surface, then we will get different formulas. Let me check whether I am getting a different formula or not. Okay, so I take x dash, this is r. Okay, so again I will take alpha, beta, gamma like that. I will play with this. Okay, this I am writing here as r. Okay, so let us take this angle as alpha, this angle as beta, this angle as gamma. All that I will write it. Okay, then again this height is h, you take per acceleration. H or y, I have taken y. Okay, so now let us try to calculate tan alpha. So tan alpha I will write as y by x. This is same as alpha as y by x. Then I will write tan beta. tan beta I will get as y by r. I will write this as beta equal to y by r. Similarly, now I will write as tan gamma. Tan gamma I will write as y by x dash. So gamma is equal to y by x dash. Okay, this I will write. Now, exterior angle, if I see, here beta is like exterior angle, so things are going to change. It will not remain as same. And I is equal to alpha plus beta here. We are getting I is equal to alpha plus beta. So let us put alpha plus beta y by x plus y by r. And here this beta is equal to r plus gamma. Beta is equal to r plus gamma. So from here r is equal to beta minus gamma. Beta is y by r and what is gamma? Y by x dash. Y by x dash. Now let us substitute as n1 sin I is equal to n2 sin r. So n1 into I is equal to n2 into r. Now substitute I. Y I will take common, so 1 by x plus 1 by r. N2 into here y again I will take common. So what do we get? 1 by r minus 1 by x dash. Y is going to get cancelled here. Same way. Now let us open and check what do we get. N1 by x plus n1 by r is n2 by r minus n2 by x dash. So we are getting as n2 by x dash plus n1 by x is equal to n2 minus n1 by r. What is happening here? Here we have got as n1 minus n2 by r. Here we are getting as n2 minus n by r. What is happening here? Nothing is happening. Try to put the convention properly. So here, if you take u, so object is distance is minus x. If you take v is equal to plus x dash. If you take radius of curvature, it is positive, so r is equal to plus r. Let us do the substitution here in this. Right? Let us do the substitution here. So x I will write as minus u. So n2 x dash I will write as v. X I have written as minus u. N2 minus n1 r I have written as r. Did we not get the same formula that we were thinking? We have got the same formula. That is why the formula is not going to change. If you take concave surface, then here it comes as n1 minus n2 by r. If you take this type of surface which we have taken as convex surface, then it is coming as n2. Things changes automatically. The raw formula adjusts itself so that this remains same. So whether you take a concave surface and derive convex surface, you derive, raw formula will change. The raw formula and 2 by x dash plus, and this left term was same there also, but here it was n1 minus n2 by r. Here it has become n2 minus n1 by r. Automatically things will change because raw will change. Now when you substitute with proper sign convention, you will get the same formula. This formula is not going to change whether it is a concave or it is convex, because this you are using with proper sign convention. It's a very important formula. This formula we need to learn how to use problems. Okay, right? So now if I consider that surface as a flat surface, if you consider surface as a plane surface, plane refracting surface, plane refracting surface, then you need to learn one thing. What is that? R is going to be infinity, either plus infinity or minus infinity, right? Minus infinity when surface is like this, plus infinity when surface is like this. If that doesn't matter, because 1 by infinity is anyway 0. So what you are going to get it for plane surface is n2 by v minus n1 by u is equal to 0, and this is what last class we have proved that. So n2 by v is equal to n1 by u, then v is equal to n2 by n1 into u. This is a very important formula for a plane surface. Suppose this plane surface and this is the object at a distance of u, and then image. Note that image is in the same side of object. It's a very important thing. Image is same side of object. So maybe image may form here. Okay, image is same size, so image is this distance v. It may be larger or smaller depending on this ratio and 1 by n2, right? Depending on the ratio and 1 by n2 it is. Now let us see. Suppose for example this is a flat surface and this is the first medium and this is second medium, and let us take object in this medium. This distance is u. Suppose if I consider n1 larger than n2, then the image will be formed here somewhere, and this distance of image, which is v, will be given as, using this formula, n2 by n1 into u, and definitely n2 by n1 is smaller than this, so this distance is going to be smaller than u. That means what? That means if I consider this is object, then this is image. Image shifts, image, this I am taking as denser medium and this I am taking as rarer medium. Okay, so image is shifting little bit above the object. This is the example of water air. If object is inside water, its image will look closer to the surface. That is the important idea, and this is called shift. Then this shift can be calculated. This shift is equal to this distance you subtract it. When you subtract this distance, you will get what? You will get subtracted. So 1 minus n2 by n1 times u. This formula is the shift. This formula is called shift. And this formula is called normal shift. Normal shift means along this same line it is shifting because image is shifting along this same line. This is called normal shift. Right? Yes, are you getting this? Lalit, Sanjay. Okay. So let us go to the next. So now we are done with this normal shift and this. Then we are going into the lenses. Now let us go for lenses. Also, before going into lens, very important thing is the power of a refracting surface. How to calculate power of a refracting surface? Power of a refracting surface. Power of a refracting surface. So suppose if I take this surface n1 and 2, optical center, object, image. Okay, this distance is x, this distance is x dash. Okay, how do I define the power? If you just see the formula which we have got n2 by raw formula, we have got this n2 by x dash plus n1 by x is equal to n1 minus n2 by r for this type of surface, because here center is here, so this distance is r. But when we have transformed into the normal formulas with sign convention, n2 we have v minus n1 by u is n2 minus n1 by r. Suppose if I consider the focus. What is focus means? If you keep object at infinity, minus infinity, then the distance v is called focus. Let us try to do that. So this will be n2 by v, which is focus, minus n1 by object distance is minus infinity, and this is n2 minus n1 by r. So from here, what do you get? N2 by focus, this becomes 0, is n2 minus n1 by r. Okay. So note that this term which we are getting, this is of course focal length we can calculate from here. Definitely we can calculate this focal length. Okay. But uh, where are we considering the, how do we take power? Okay, this we have got power. Is power 1 by f? Is what is power? How do you define power? Let me check that. What is the power? Power will be 1 by f or n2 by f. What do you think? Let me check. because power definition for surface is different. Surface, did you see the modules? In the modules, let's check that. How power for a surface is defined. Power for a surface is defined. Power of a refracting surface. This power is defined as um, reduced focal length, based on reduced focal length they define. Okay? Defined in a different manner. Hmm. This concept we have to understand. Principal foci. There are two principal foci, okay, that we need to understand. Principal foci F1, F2. Here itself you will understand principal foci, then we can see here. So this definition, if you see in the modules also, it is defined as minus that way. Okay, but I think this is called reduced focal length, mu1 by f1, mu2 by f2. Okay, let us just check about this, then we will come back to this. Okay, so what is power is defined here. Power is defined in a different manner here. Okay, before coming to power, using this formula, we will understand principal foci. Then we will discuss that power. Principal foci, let us understand. So this surface has two first principal focus and second principal focus. First principal focus. How is first principal focus defined, and how is second principal focus defined? Second principal focus. How is these two principal focus is defined? Look at the definition of that. What is the principal focus? If object is kept at infinity, then where the image is forming, that is the uh, object is kept at infinity. Suppose you keep object at infinity, then the focal length is the second principal focus f2. Okay. So if I consider the second principal focus only, I am trying to define here as that. Let us call it as f2. So u I keep minus infinity, v I have to keep as f. Okay. Then use this formula. So n2 by the same formula we are, and note that in this surface we have taken concave surface, right? This surface I have taken concave, so r I have to substitute as minus r in this formula. Remember this, I have to put r as minus r here. Okay, right. So use this formula. This formula we have got this focus we are getting as f2. Okay, note that this we are getting f2. So if I am using this n2 by f2 and this minus n I will take here, please. F2 I can calculate from here. Don't worry, we can calculate F2 from here. So F2 I can calculate as minus N2 times R by N2 minus N1. This is the second principal focal length. Okay. But this term which we are getting as minus N2 by F2, this is what is called power. This is called power. Okay. This is, now you have to note. This is what is called power. Similarly, what is first principal focus? What is first principal focus? How do we define first principal focus? First principal focus means if I keep object, note that here you are taking, in this case you are taking parallel rays, and parallel rays are meeting at the focus, right? That focal length is f2, that is what we are calculating here. Okay, so u we have taken as minus infinity. But now if I take first principal focus means I will keep object here. Object is kept at the principal focus length f1. And then if you take some rays coming from here, these rays become parallel. That means u is given as minus f1 and V becomes equal to plus infinity. Let us try to substitute this in that formula and check what is the second principal focus. Sorry, first principal focus. Let us try to substitute this condition and try to find out first principal focus. So N2 by V minus N1 by U is N2 minus N1 by R. This is what substitute. N2 is that medium, N2. V is going to be plus infinity minus N1. U is going to be minus F1 is equal to N2 minus N1. And here R is also negative I am taking, so minus R I am taking. So from here I am getting N1 by F1 is equal to N2 minus N1 by minus R. So from here F1 I can calculate. F1 I will calculate. What is F1 will come? F1 will come as minus N1 times R by N2 minus N. But note that here power also will be defined by the same formula. Power will be N1 by F1. Okay, which is coming as same as N2 minus N1 by minus R. Note that the power definition here and power definition there, this power which we have calculated, what is that power we calculated here? Power we have calculated at this power definition here is minus N2 R by N2 minus N1, right? No, N1 by F1, sorry, N2 by F2. Minus we bring it, minus we bring it. I think that will be coming different now. Check that, they are not going to be same, right? This power definition, if I define power this way, this is minus N2 by F2, which is going to give us N2 minus N1 by R. This power we are defining here like this way. Here, how are we defining this power? We are defining. So, let me check the definition whether the definition of power are correct or not. Power is N2 minus N1 by R. They are defining it. N2 R by N2 minus N1. N2 minus N1 by R. These two are changing by a sign of minus, right? Both should be same. N2 minus N1 by R. That's the definition of power. Here the definition N1 by that minus is coming N1 by N1 by F1 or minus N2 by. Okay, for this surface you can define like this way, because N2 by, so here you may define this as, might be here you can take this as minus N2 by F2 and 2 minus N1 by R, depending on whether it is converging or diverging. How do you know whether it is converging or diverging? If parallel rays are converging, then you can say it is a converging. Then power has to define positive. For example, this way. If this is converging, then power has to be positive. For example, what we have defined that. That should be defined as the power. So I think here this minus definition you have to take this side. Okay. So this minus we are getting here focal length. Did we substitute F1 value proper? No, no, no. I think no. Minus F1 we have substituted. Okay, we have substituted F1 here. This minus is coming extra. Minus is coming. Okay, club this minus then here. Club this minus this side. This minus. Should I club this side or not? That is what it is. So we need to get N2 minus N1 by R. So minus, I think you need to bring this. Correct this one. In the book it is defined differently. Okay, so bring this minus here in this case. Minus we bring it this case. Okay. So this power is minus n1 by f1, which is n2 minus n1 by r, and this is also coming as minus n2 by f2, which should give us same as n2 minus n1. Are they giving the same? Let's check here that n2, this minus I have taken, so minus times n2 by f2 it is coming, and here also we have taken this is minus n1 by f1. So the idea is that power can be calculated as n2 minus n1 by r, either this way or that way. But when you are using first focus, you have to write minus n1 by f1. When you are writing second focus, you have to write minus n2 by f2. Are you clear about this? Yes. So this is called the power of a what? Refracting surface. What type of surface? Spherical surface. Are you getting this? Yes. Power definition is given by this. Okay. Then let us move to the next. But note one important thing, that the same surface cannot be converging or diverging. Right? Same surface cannot be converging or diverging. So might be I have defined it for the same surface, which might not be good. So I have defined for the same surface, but if you see in the module, that is the proper definition, I think. Yes. Let me just redefine it again. So if I consider this type of surface, okay, this type of surface, and if I consider the rays are converging like this way, the rays are going to converge like this, okay. So u is equal to minus infinity and v is equal to, so the parallel rays are converging. So this is what, which focus? This is second focus. This point will be f2. This length v will be f2. Okay, now you use in this formula n2 by v is f2, minus n1 by u is minus infinity, is n2 minus n1 by radius of curvature. So this radius is positive only, so let us write plus. Okay, so from here we get n2 by f2 is equal to n2 minus n1 by r. Right, that's the definition. Okay, from here we can calculate f2. F2 can be calculated as N2 into R by N2 minus N1. This is how F2 is calculated. How do you calculate power? Power, how do you calculate? So the power is defined as, in this case, we can define power as, um, power is defined as this 1 by this, N2 minus N1 by R, that is different. Okay. But for, let us calculate for second surface like this. If I consider this type of surface, I think they have taken different type. No, same surface they have taken, and they have defined f1 and f2. Hmm. Same surface also they are different. Okay, let us try for this surface. If I take object here, then this will be the focal length f1, and this will be u. U will be written as minus f1. Then rays are going like this. These rays will become parallel. Then v will become plus infinity. And if I use the same formula, n2 by plus infinity minus n1 by u is minus f1 is equal to n2 minus n1 by r. R here is this r. This r is positive, both positive only. Okay, so from here what do you get? I think we are getting the same. N1 by f1 is equal to n2 minus n1 by r. We can calculate f1 from here, which is n1 r by n2 minus n1. So this f1 and this f2, which we have defined, they are not the same. N2 r by this is n1 r by this. I think denominator factor is same, n2 minus n1, n2 minus n1. This is just multiplied with n1 r, that is multiplied with n2 r. So that is why if you take ratios of f1, f2, you will get as n1 by n2. This is the important rule. Okay, this is the ratio. Hmm, that's the ratio. Okay. Now this is the important thing to note, that note this point, that n2 by v minus n1 by u is n2 minus n1 by r. Okay. Now what I am going to do is, let's try to note important thing. Suppose if I write this r, but this factor I am bringing like this, dividing using this factor I divide. So n2 by v, if I divide it, I will get n2 minus n1 r here, n1 also r by n2 minus n1, and this is u here multiplied is equal to 1. So see that n2, this r by this is nothing but f2. This is f2 by v minus this is f1 f1 by u is equal to 1. But I think with proper sign we need to substitute. They have substituted with sign. They need to substitute with sign. Yeah, they need to substitute with sign. So with the sign u they are substituting as u, they are substituting as minus u, so plus they are getting this. This result is an important formula. F2 by v plus F1 by u is equal to 1. Okay, anyway, so this power formula is defined like that. Power is n2 minus n1 by r. Note down this power formula. Okay, focal length f1 they are defining as negative. Why are they defining this negative f1? F1 they are defining as negative. F1 they are defining as negative. Here f1 they are defining as negative. I think this is the major confusion here. F1 they are defining as negative. Hmm? F1 they are defining as negative. Might be because it is this side, so might be they are just putting u as f1 because we don't know which side it will come. Automatically it is coming as negative side. Magnitude wise it is this. So I think this f1 they are defining as negative. Okay, note that f1 they are defining as minus of n1 r by n2 minus n1. Okay, this they are defining. Okay, so that's why this term is becoming plus, otherwise this will become minus 1. Okay, this they are taking with sign. Why they are keeping why do we need to keep? This is a question I think here. Why should we keep f1? Because f1 is coming this side, so that f1 represent magnitude. Okay, so that is why they are writing f1 by u plus. So this is another way to write that surface. But anyway, in all that cases, you note that the power of the surface, power of refracting surface is equal to n2 minus n1 by r. This is with proper sign. Okay, this power formula, remember that. Okay, then let us move to the next. Motion of object and image with respect to spherical surface. Okay. Motion of object and image. Next topic is motion of object and image with respect to refracting surface. Refracting surface. So suppose I write this formula as n2 by v minus n1 by u is equal to n2 minus n1 by r. And this is for a surface where this is object, let us say. Object distance is u, image distance is v, right? Now if I differentiate, remember this is only horizontal motion we are talking about. So relative to mirror, mirror may also move, but in this direction, this we are going to write that. Okay. So if I differentiate n2, 1 by v differentiation will give minus 1 by v square. Okay, into dv by dt minus n1, it is again minus 1 by u square. This is du by dt, and this side becomes 0. So note here that this n2 minus minus plus, that will become s. So minus is coming, v square dv by dt is the velocity of image, vi I am writing, minus image with respect to mirror it is, okay, relative to mirror it is, minus n1 minus minus plus n1 by u square du by dt is velocity of object relative to mirror. So from here velocity of is coming as image velocity is coming as, this will become plus, so n2, no, this will go n1 by n2 into v by u whole square times velocity of object, right? This is what we are getting here. Let me check that whether this is correct. Hmm. V by u whole square and 1 by n. Correct only, I think. But this V by U we can write as lateral magnification, I think. Lateral magnification we have to write. I think in the book they have made a mistake. That dv by d2 is n1 by n2 v by u whole square, they have written it. That's correct. But I think they have made mistake. They have made mistake here. Hmm. They have made mistake here. Textbooks, you see, when you are looking at the textbook modules, there is a mistake here. You have to read carefully. Okay. So this is the correct formula. In the module, there is a mistake given in the formula. This n1 by n2 into v by u. V by u is magnification, lateral magnification they are calling it. So vi is equal to n1 by n2 into lateral magnification square into velocity of object. This formula is the correct formula. In the textbook, they have made mistake as n2 by n1. So note this. Okay, there is a mistake in the textbook. Okay, so this is an important formula. If they ask questions on this, that we can do. Net magnification by series of net magnification formula. Hmm. That's not important. There may be different, so that we can do that. Net magnification by series of spherical surface. That also you note it. Net magnification formula. Net magnification formula. Net magnification formula. And here you may ask question that how did we get the lateral magnification formula like that? Because till now we have not considered that. Suppose if I consider some object here, or this is the height of object. Let us write this as y. And we have seen that the image may form this side somewhere. Hmm? How will the image form? If you want to take rays and try to form it, right? So suppose if I take some rays and this side it will be forming. How do we take the image? Because for object here we have taken that side. Image, where do we take? Let us take some rays and try to see that. Suppose this side take one ray. This is the angle of incidence here. This ray will be converging like this way. Right? Let us say it goes either towards normal or away from normal. This is R. Okay. One ray I can directly take like this way. Right. So definitely this image will be lying somewhere here only, because this is these two rays. Some more rays of course we have to take. If you want you can take some more rays. How do I take more rays? You may ask, how do I take more rays? Then how do I take more rays? If I take some rays hitting here like this, let us take some rays like this hitting here, and here normal I have to draw. So I draw the normal here. This now this is some angle, other angle of incidence. So this ray may go like this way, and it will be hitting somewhere, right? So I will get this image here at this point. So this is y dash. Note that this is y dash. Already we have found relation between x dash. Remember, this is already I have taken as x, and this already I have taken as x dash. We have got relation. What was that? N2 by x dash plus n1 by x is equal to n2. No, it was n1 minus n2. n1 minus n2 by r it was. Correct? This is what we have got it. This result we have got. Okay, right now. Now let us try to find relation between this. So note very important this. If I use tan I formula. So tan I will be y by x, and tan r will become y dash by x dash, y dash by x dash. Correct. So if I use, and tan I is very small, so this is same as I, and this r is also very small. This is r. So I by r ratio we are getting as or are these angles equal or what? I think these angles are equal. No, no, no. Why this angle has to be equal? No, no, no. These angles are not. Apply Snell's law. Snell's law we apply. So Snell's law when I apply, what do you get? Snell's law when I apply. So n1 sine I is n2 sine r. So I got n1 into I as n2 into r. So now let us substitute I. I has become y by x, and n2 r has become y dash by x dash. So here lateral magnification, let us define lateral magnification as y dash by y. Lateral magnification y dash by y. So y dash by y is coming as n1 by n2 is coming as n1 by n2 into x dash by x. This is important idea which we are getting, hmm? Isn't it? And 1 by n2 x dash by x, isn't it? Hmm. The I and r will not be equal. I and r will not be equal, but this is how the magnification for this surface we are getting. Hmm? What in the book they have given this magnification? This magnification in the textbooks they are uh, not giving it. They are defining this as x dash by x dash ratio v by u. They are taking as this magnification y dash by y is transverse magnification, and x dash by x is lateral magnification. Note this. I think this is important idea. Okay, this is important idea. So this what is lateral and what is longitudinal? So what we know m is longitudinal. We know as longitudinal like this way, that we do not know. Y dash by y, that we know as lateral. Okay, lateral only know as y dash by y. But what is this magnification x dash by x? X dash by x is not the same magnification. X dash by x is longitudinal magnification. Y dash by y is lateral magnification. In the textbooks they have got confused, I think, full confusion that is. Huh? They have not defined which it is. Yeah, too much confusion they are doing to it. Magnification they are defining as 1 by n2 as v by u. So this magnification is what magnification? lateral magnification. Okay, note that this magnification y dash by y, this is lateral magnification. Lateral magnification. Okay, this they are defining as lateral magnification. Okay, okay. So the previous formula that we have seen now I think previous formula we can correct it. This formula which we have seen here as Vi, which we have got it. This M is what? M is not V by U. Like this. So we need to correct this one. Right. Oh, so this magnification V by U is what? Here note that we discussed lateral magnification Y dash by Y. That magnification is N1 by N2 into that x dash by x, which is nothing but x dash by x, which is like V by U. So this is N1 by N2 into V by U. That is what it is. Right. So from here they define this V by U terms as N2 by N1 into M. Now this we substitute here, then this velocity of image comes as, anyway this formula is correct, but now when we substitute this, it will come N2 by N1 whole square into M square into V naught. So then Vi comes here as N2 by N1 into M square into V naught. This way you can also write, correct? Right. So you can write as N1 by N2 into V by U whole square into V naught, or you can write N2 by N1 into M square. What is M? M is the ratio. M is not V. M is not V by U. M is not V by U. M is the ratio of Y dash by Y. M is this one. Any confusion? Okay. So M is that. Okay. Are you getting this? So this is very important to note this. Then that's how this M was coming. Now we are derived. That's why always we should remember how the derivations are coming. The scratch rule, the raw formulas. That's how it is coming. Okay. That's why this M, which we are writing as Y dash by Y, Y dash by Y, this is N1 by N2, and this X dash by X is like V by U. You can put with proper sign, that's okay, but we can write it like this. Minus also you can put, because X dash is like here we can write as V, this you can write as minus, so it doesn't matter, because you have to take a square and it will come automatically. We don't have to worry. And here see y dash is here negative now. So with that, if you write as minus height of image minus all those sign convention we can do. That's why I never want to write it in terms of V and U. I want to keep as raw. Then we'll put it afterwards. Okay. So that's a very important formula. And now coming to this net magnification formula here. So suppose for example there are many surfaces like this, like this, like this, so many. And suppose this is the common optical and this is height of the object. So first time this is first surface will make height of image h1, then it will reverse as h2, this will reverse as h3, like that it will keep on happening. Let's say this is final image. We don't know which direction it is forming. It may form this way or that way. Okay, like that I have taken. So how do I calculate magnification? That's important. So magnification of first surface, this magnification which is producing is h1 by h0. They are taking. Similarly, the magnification of other surfaces are like that. So net magnification, how do we calculate? Net magnification we calculate as final height by initial object height, which you can write as m1 into m2 into all that into last final mn, let us say. So this how it will come, because for the first one it is height h1 by h0, this will give h2 by h0 into this will give, sorry, h2 by h1, it will give h3 by h2, like this it will give, and finally it will come h final by h before that and minus 1, like this. So these terms, all these things will get cancelled out. Okay, all these terms will get cancelled. So that's why you will get only HF final by H0. That is called total magnification, which is the product of all that. Okay, M1, M2, M2 is 2 by H1, M3, like that it will go. So you, all this magnification you multiply it, then you get total magnification. That is the approach, because sometimes they can ask for total magnification. We will calculate like this way. Clear? Very, very important things, because this chapter is quite a big chapter. Lot of concepts are involved, and the class times are very less. We cannot cover all these things unless we go into all the details of the concept. Difficult questions you cannot solve, right? So it is very, very important to work out questions of difficult level, then only we can solve it. Okay, so next let us finish that lens maker formula. Now we are going into lens maker formula. Lens maker formula. Lens maker formula. So lens maker formula means now there are two surfaces. These curvatures are R1, this curvature is R2. All these are thin lenses. All these are thin lenses, and all its paraxial rays. These are important things. Paraxial rays only. So let us consider some object here. Okay, some object here, and try to make image, right? So final image will come somewhere here. This is the final image. So intermediate images will come. So let us take first refraction through this surface. So suppose if I take one ray, I can take directly going like this way. Nothing will happen to this ray. Take another ray going like this. If I consider this ray, here I need to consider normal. So if I consider normal here like this, the surface, then this ray I have to consider going like this way. Let us say it is going. Now I am not taking the second surface right now. If I want, I can show it like this reflection also. Let us consider that it is going like this way. So this image, intermediate image I1 has formed. Now at this surface again I need to consider refraction. So again I will draw a normal here at this surface. Normal here I will draw. Okay, so this is angle of incidence. It may go away from normal. So that's how this actual the ray will be going like this way. Ray will be going here like this. Okay, so this is how the actual diagram in your board exam you have to draw. Otherwise you will not get marks. So you need to show refraction happening at two places. One is refraction happening here, another. Okay, so this is the object distance. I am taking this as x. Afterwards I will put it. I want always raw formula. This is x dash. Okay, x dash. And intermediate which it has formed, I will take that as what? Or let me just write direct formulas. Okay, maybe now I will, because I know u and v. So let us consider this as u, and this is the final image which is v. I am going to take this intermediate which is coming. I will take v1. Note that this image I1 is an intermediate image which is a virtual image. Okay, so first let us consider this surface. Try to understand properly, because in NCRT they have again confused in NCRT. So this surface let us study, and I am going to keep this medium as N1 and this medium as N2. Outside I will keep again, I can keep N3 also, but let us keep as N1 only. That means this lens is put in an outside medium same. So now apply for this refraction you apply. So N2 by V, V means V1 minus N1 by U is equal to N2 minus N1 by R. R means R1 here. This is the first thing. Next, I will take this second. When I am taking this second diagram, second means I am now taking this surface. This surface I am taking. For the second surface, light is going from N2 to N1. So this is second medium. So I will write N1 by final image minus N2 by object. Object is V1. Now that V1 will be acting as object. and we have to write as n1 minus n2 by r2, and then we have to simply add these two equations. So add these two equations, first plus second, add. You will see that these terms are getting cancelled. That's what will happen. So you will get n1 by v minus n2 by u is equal to, now I am going to take n2 minus n1 as common. So this will become 1 by r1 minus 1 by r2. So from here I am taking, uh, now here important thing is that what is the focus? This is absolutely correct, but I am going to write this as object. I am going to take as infinity minus infinity, then v will become equal to focal length. Which focal length? Obviously this is second focal length. You don't have to worry, but I am writing here as second focal length, second focal length, which is f2. So let me substitute this. So n1 by f minus n2 by minus infinity is n2 minus n1 r1 by r1 minus 1 by r2. So from here we will get, this is going to be 0. So this is n1 by f is equal to n2 minus n1 1 by r1 minus 1 by r2. Now here you will say, should I not take n1 by f? No, this is not definite power. For the lens which has two surfaces, 1 by focal length is defined as the power. So power of this lens is defined as 1 by focal length. So this n1 will go that side. So n2 by n1 minus 1, 1 by r1 minus 1 by r2. This formula is called lens maker formula. Very, very important, lens maker formula. Lens maker formula for thin lens. For thin lens. Okay. Thin lens, we can define lens maker formula like it. Clear? That's how we define lens maker formula. Then you will say, how do we write 1 by v minus 1 by 1 by for the lens? That is grade 10th you have studied, but now I will derive that formula also very quickly. Okay, there is nothing a big thing in that. Suppose this is a lens. Okay, this is a lens. I am taking this, no, made of same material. Okay, some material. So when I keep this as the axis, optical axis, and I take object here. Okay, I take object here. So this distance become x and this distance become y. Okay. So when I try to form images, right? When I try to form images, I can take a parallel rays. This will pass through the focus. You know those rules. You know. This is the second f2. So this I am defining as f. You know, f. This is f2 only. In this formula, f is f2 only. No need any confusion. This f2 only we are taking as f. Okay. So, where the image will be formed, let's take one more passing through center we can take. So, take one ray passing through center, it will go like this. So, these two rays are going to meet here, right? This point, so this is the image, this is the image, this distance, okay, right? So, this I am defining as x dash and this I am defining as y dash, okay. Now, we can definitely able to calculate using very simple trigonometry. Very simple trigonometry. Suppose if I take this angle as some angle I take, let us take alpha. So this angle is also alpha, you know. If I take this angle as beta, this angle is also beta. And let us call this is nothing but y only. So now let us try to take some triangle. Suppose if I take this triangle, so tan alpha in this triangle is y by x, and this y by x in this tan triangle, it is y dash by x dash, y dash by x dash. Okay, right? Another thing is that let me take beta. So if I take tan beta in this triangle, tan beta, it becomes y by f, and if I take in this triangle, it becomes y dash by this distance. This distance is x dash minus f, right? This distance. So I will take as x dash minus f. So now if I try to calculate try to eliminate y dash by y or y by y dash. So I will get as x dash by x. Let us take x dash by x as y dash by. So y dash by y, y dash by y from this will come as x dash by x, and same y dash by y, it will come as x dash minus f by f. Now try to use this formula, this part let us use, and you will get what? Try to multiply. So x dash into f is x dash minus x into f. Okay, and bring f one terms one side. So you bring this x dash f terms one side I want to bring. So x dash plus x I will take, f I will take common, and this is x dash. Okay, so from here, if I write this as x dash plus x by x dash is equal to 1 by f. Now I will write this as 1 by x plus 1 by x dash is equal to f. It looks like mirror, but it is not mirror formula. I will now put the sign convention, because u I will put as minus x, v I will put as x dash, focal length I'll keep as it is. So here you will see 1 by x dash become 1 by v, 1 by x become minus 1 by u, this 1 by f. This is how are we getting the length formula, which is a grade 10 topic. But simply by trigonometry we are calculating this. Are you getting this? Yes. Lalit, Sanjay. Yes. Are you getting this? Yes. Lalit, Sanjay, Sam. Now you have joined Hari. Okay, so I think today we have covered a lot of conceptual things in this chapter, and let us wind up till here. Okay, then we'll continue in the next, right? So I'm also expected to start grade 11 class. So grade 11 student, how many are joining today? He is supposed to join. Let me check whether he will join or not. So let us wind up this class, grade 12 topic up to this. Then we will continue that, right? Okay, so let us wind this grade 12 topics. Then I will be starting grade 11 soon. So let us wind up this. Okay, fine. So we'll continue discussing further on this, right? So thank you all. So let us wind up this session. I will stop the recording. Those who want to be